Welcome back to lesson 6.3. Let's do example number 5 where we do another example of u substitution. Now, one of the trickiest parts of u substitution is trying to decide what your u should be. Should my u be 3x minus 1? Should it be to the 10th? Should it be lots of different things? 90% of the time, your u should be whatever is in the middle. Kind of going back to that chain rule thing. So our u needs to be whatever is inside something. So this one is inside to the 10th power, inside the parentheses. In number 7, this would be our u, because it's inside the root. 90% of the time that works. Your u should be whatever is inside other things. So we're going to set this up. U should be 3x minus 1. So du, my derivative of u, du dx, there we go, should be 3, the derivative of that top line. And just like we did in this first video, I'm actually going to move the dx to the other side. So I have du equals 3 dx. So now let's put some things in. Here is my u. Now this, like we saw in the video 1, should amount to our du. But notice here at the du equals 3 dx. Whereas this one is just dx. So we're missing a 3. So what we're going to do is just put it in there. But if we just put a 3 in there, we're actually changing the equation. So kind of like when you add something to one side of the equation, you have to add it to the other so it stays balanced. Well, I'm going to put a 1/3 outside this integral to keep this whole thing balanced. And to kind of help you see what I mean by that, remember we learned that if there are any numbers times an equation in your integral, we can move them outside. Well, let's take this 3 that we added just for a minute and move it outside. Well, then I'd get 1/3 times 3 on the outside, and then my integral just like I had it. Well, this is just basically a complicated looking 1. That's why if I put the 3 on the inside, I have to put the 1/3 on the outside to keep it balanced. Because then I'm really just adding a 1 in. And I can add that 1 and it's not going to change anything. So you can add these numbers in here to get the du that you want. But don't forget to add the reciprocal to the outside to keep it all balanced. So let's rewrite what I've got now. I've got 1/3 on the outside. I got my integral. This whole thing is u to the 10th. And then this whole thing is du. So double check. This says du, so it should be in the language of u, meaning I should only use the variable u in my integral. Only using u? Check. So now I can take my integral. This is just a power rule, so it's going to be u to the 10 plus 1 over 10 plus 1 plus my constant of integration. So I've got 1/3 times u to the 11th all over 11. And then last step, let's substitute u back in. Oops. So my u is 3x minus 1. And there we go. All done. Okay, let's try number 7. Now, before you get started on number 7, I'm going to slightly rewrite this. I'm going to rewrite this as 1 over square root of 4x cubed minus 5 times 6x squared dx. Which we know is the same thing because this is just multiplying across. So these top and bottom, that's the same thing. But having it written this second way is going to help you see your du a little better. So I already told you that u needs to equal 4x cubed minus 5. Now what I want you to do is to pause the video and try to finish this problem. You have u, you need to find du, and you're going to have to add a number in again and add the reciprocal to the outside to get your du, and then try to solve it from there. So pause the video and try this out on your own, and then come back and see how you did. Back, let's do a little check-in and see how things are going so far. So first I took my derivative, du dx is 12x squared. Brought my dx over to the other side, so I got du equals 12x squared. So this is what I want to be my du, but right now it's only 6x squared. So I'm going to times that by 2 so that I get the 12 that I want, but then I need a 1/2 out here to keep it balanced. So now because I times that by 2, that's my 12x squared dx, so that is my du. This inside is my u. So this is what I should end up with now. Now, I'm going to rewrite that square root of u as u to the 1/2, and then bring it up into the numerator so I can do power rule. So it's going to be u to the negative 1/2. Those two things are the same. And now you should be able to do your power rule and then substitute u back in. So pause the video again and keep trying to finish solving it from here. Let's check what you got with what I got. So we had 1 over square root of u, which was u to the negative 1/2. Did our power rule. Hope you're okay that I skipped that step of just adding 1 to it. I figure we're getting pretty good at the power rule by this point. So we get u to the 1/2 over 1/2. I do my leave, flip, change rule where I leave the numerator, flip the denominator, and then change the division to multiplying. And then I noticed I had a 2 on bottom and a 2 on top that canceled. Oh, and I have my constant of integration. So this is what I ended up with. Change that 1/2 back into a root, and then plug u back in, and we're done. There we go. In the next video, we'll do a couple more examples of this u substitution stuff.